Okay, so our last unit we talked about matter, and we said that matter is anything that has mass and has volume. So it has to have those two things. Okay, so if it has mass or it's made out of atoms, and if it takes up space or has volume, we call that matter. And we discussed there's a couple things that in the universe that aren't matter. And really, if you break down all those things we listed, they fall into two categories. One is empty space. So if I have a volume of something with no atoms inside of it, we take all of the atoms out of it, then you have empty space. And empty space is not matter because there's no mass. Okay? The other thing was energy. So all those other things that we listed, like gravity, magnetism, all those things can fall into the category of energy. So really, there's only three things that make up our universe: matter, empty space, and energy. So we're going to talk about energy today. All right. So let's define energy. Energy is the ability to do work. All right. Well, we need to know what work is for us to understand what energy is. So energy is the ability to do work. So what's work? Work equals force times distance. That's the formula for work. All right. So for work to happen, there has to be two things that take place. There has to be a force. So a force is any push or pull that transfers energy from one object to another. So when you push something or when you pull something, you are transferring energy from your body into that object. The next thing that has to happen for work to take place is it has to move a distance. Okay, so our bobblehead here. If I take this bobblehead and I apply a force, so I take the energy from my body and I push the bobblehead and it moves a distance, I'm doing work, right? So I'm transferring the energy from my body into the bobblehead moves a distance, so we're doing work. Energy is the ability to do work, all right? Now, sometimes we can push on something and no work take place because it doesn't move a distance. For example, I can push on my desk here, but because my desk is secured to the ground, it won't move. So I'm applying a force and I'm transferring the energy, but work's not taking place because it's not moving a distance. Okay, so energy creates forces that moves objects that allows us to do work. Okay? So, while there are many different forms of energy, all forms of energy can be put into two categories. So, we have kinetic energy and we have potential energy. Okay? We're going to focus on kinetic energy today. So we'll look at kinetic energy, and then in a couple days we'll look at potential energy. All right? So kinetic energy. Kinetic energy is defined as energy an object possesses because of its motion. So a lot of times you'll hear people say kinetic energy is energy in motion. All right, so when an object is moving, it possesses kinetic energy. Kinetic energy of an object changes when its speed changes. This is an important concept. So, when an object speeds up, then kinetic energy goes up because our motion, we have more motion. The more motion we have, the more kinetic energy it possesses. So, when an object speeds up, kinetic energy goes up. That should be easy to remember because it's directly related, up. When an object slows down, then kinetic energy goes down. Okay, so again, directly related, down, down. If an object travels at a constant speed, then kinetic energy stays constant. So kind of think about it kind of like this. And when you're in your car, when you hit the accelerator, your speed's going up, so your kinetic energy is going up. When you hit the brake, your speed's going down, so your kinetic energy is going down. When you have the car on cruise control and you're staying at 55 miles an hour, your kinetic energy is staying constant because your speed is staying constant. Okay? So kinetic energy is energy in motion, or energy an object possesses because it's in motion. All right? So here are some examples of kinetic energy. And we're going to look at each one of these individually. Sound, heat energy, sometimes called thermal energy, electrical energy, and electromagnetic energy. Okay? So let's look at all these. Sound energy, sometimes called acoustic energy, like you have an acoustic guitar, acoustic energy, or sound energy. Vibrations of atoms or molecules. So, as I'm talking to you, I'm creating sound energy because my vocal cords, so if you're at home or if you're here at school or whatever watching this video, if you put your hand on your vocal cords like this and kind of hum or talk, you'll feel them vibrate. Okay? And those vibrations are causing the air to vibrate. So the air is actually creating what we call a compression wave. So the air molecules between my throat and your ears are causing little collisions. So this air molecule is hitting this air molecule, hitting the next one, hitting the next one, hitting the next one. And then it's getting caught by your ear. Your ear's designed to catch compression waves or sound waves. It goes into your ear, and then you have your eardrum that vibrates and hits these little bones and sends signals to your brain. Okay? So sound is energy. It's movement. All right? Sound has three parts: wavelength, frequency, and amplitude. Okay? So lots of times you'll see people diagram sound or wavelength kind of like this. So let's say this is 0 seconds. Let's say this is 1 second. Okay? And you'll see people all right. So that's kind of freehand. It's not very good, but people will draw a sound wave kind of like this. Okay? And this wave has a couple parts that we need to identify. First of all, this is called the crest. So the top of the wave. And this is called the trough. I think I spelled that right. Let me check. T-R-U-G-H. Close. Okay? So, like when you get to the top of a mountain, we call that the crest of the mountain or the crest of the hill. A trough. Trough's a U shape that animals will drink out of, okay? So, wavelength, the distance from one crest to the next crest of the wave. So, you can say wavelength is from crest to crest. That's one wavelength. You could also say it's from trough to trough. Okay, I don't have the second trough in here, but if I did, we could say from trough to trough. You could also say from the middle to the middle. So a wavelength always has one full crest, one full trough. Okay? Frequency. How many times a wavelength happens every second? Okay, so here's 1 second, and I have how many wavelengths? I have, here's one full crest, one full trough, so there's one wavelength right here. And then I have one full crest, so I only have half a wavelength. Okay? So, the frequency of this sound wave would be 1.5. All right? Let's draw a different one. Let's see if this marker will work. All right, so I kind of freehand the green one there. Again, one full crest, one full trough. So here's one wavelength. There's one. Here's another full crest, another full trough. There's two wavelengths. And then I have another half of a wavelength. So the frequency of this wave, the green one, would be 2.5 wavelengths, or 2.5, okay, would be the frequency, okay? Now, the shorter the wavelength, the higher the frequency, which makes a higher pitch sound. So, the black wavelength here, or the black sound wave, has a longer wavelength, right? Because here's one wave, and here's one wave for the green. The shorter the wavelength, the more movement that has to happen. Okay, the more movement that has to happen. So the shorter the wavelength, the more energy it has. The more energy it has, the higher pitch the sound is. Okay? The next part is amplitude, the height of the waves. Now, I tried to draw these all with the same amplitude, but with a sound wave, if I draw one that has a higher amplitude, it would kind of look like all right, so the pink one, the amplitude is how high the wave is from the center. So you can see this one is higher, okay? So because it's higher, it's louder, all right? So the green and the black one, I tried to draw the same amplitude. They would be the same sound, but the green would be a higher pitch, okay? The black one would be like way down here, and the green would be like way up here, okay? Higher pitch. The pink one would have a lower or lower frequency. It would be really low, like way down here, okay? Because it's only one wave per second. But it would be louder than these two, okay? Now, I've put a video down here for you guys to watch. It explains this a lot better. If you're in band, this is a really, really good video because he explains like kind of all the parts of the sound and all that towards the end, and it'll really help you guys understand notes and things like that, okay? But the three things you need to know for me: wavelength, frequency, and amplitude. And you need to know that the shorter the wavelength, the more energy it has. The higher the amplitude, the louder it is, okay? So that's our first form of kinetic energy, is sound. All right, our next form of kinetic energy is heat energy, sometimes called thermal energy. It is the result of movement of tiny particles called atoms, molecules, or ions in solids, liquids, and gases. Heat energy can be transferred from one object to another. The transfer or flow due to differences in temperature between the two objects is called heat. So, heat energy is caused, again, by movement. That's why it's kinetic energy. Movement usually causes what we call friction, and heat is a byproduct of friction. So, for example, if you take your hands, put them together, and we rub them, our hands are moving, and they're bumping against each other, they're rubbing against each other, and your hands will start to warm up because of the friction, all right? Well, if you look at something that is filled with atoms and molecules, which all matter is made up of atoms and molecules, right? And if those atoms and molecules inside there move slow, so like I have a small arrow on this diagram here, this means they're moving slow. Because they're moving slow, there's going to be less friction. They're not going to bump into each other as much. They're not going to bump into each other as hard. So because there's less friction, there's less movement, the temperature is lower, okay? Over here, you can see these atoms have bigger arrows, meaning more movement. They're moving faster. Remember, faster something moves. When speed goes up, kinetic energy goes up. So there's more kinetic energy here because there's more kinetic energy, they're running into each other more often, they're running into each other with more force. So because they're doing that, this one over here is going to be hotter. It's going to have a higher temperature, okay? So the transfer or flow due to the difference in temperature between the two objects is called heat. So everything wants to find equilibrium or balance, okay? So if you take a cup of water that's room temperature and you put ice in it, that's cold. Ice is 32 degrees Fahrenheit or 0 degrees Celsius. The ice cubes are going to get warmer, right? Because they're in the water, they're going to melt. But the water is going to get colder because the ice cubes are going to bring that temperature down. So what this is saying is, as that heat energy flows from the water to the ice cubes, we call that heat, or we call that thermal energy, okay? There's a transfer there. So keep in mind, the faster the atoms inside the object move, the more energy they have, the more heat they have, okay? So we've got sound energy, we've got heat energy. Again, I have another video here for you to watch to help explain this a little bit more. All right, electrical energy. Electrical energy is caused by a magnetic field moving electrons. The faster the electrons move, the more electrical energy they carry. So, if you look at an atom, which we did last unit, you know that you have protons and neutrons in the nucleus in the middle. And on the outside we have electrons. And an atom itself is basically a little tiny, really small magnet. Okay? The positive charge is in the middle and the negative charge is on the outside. So when you take a magnet and you revolve the magnet, like you spin the magnet, you have the positive end and the negative end keep changing positions. So whenever the positive end gets close to the atom, it pushes that electron away, right? Because the electron is negatively charged and that side of the magnet is positively charged, so it pushes it away, okay? And then as that magnet spins back around, the negative side's over here, electrons are negative, goes to it. So you have this movement of electrons, okay? That happen all the time. Because this magnetic field is moving those electrons. Because when the positive gets close to the electron, it pushes it away. When the negative gets close to the electron, it pulls it too. And you have this constant push and pull. So we have a force, and it's moving the electron a distance. So we're creating energy because of movement. So electrical energy is kinetic energy, okay? The faster these electrons move, the more electricity they carry. So if we could really spin this magnet really fast, these electrons would really get moving and we would create a lot of electrical energy. So this is how we create electricity that gets sent to your house. We have these big, huge turbines and they have these big, huge magnets in them. And we find different ways to cause these magnets to spin around big copper coils. And remember from last unit, copper has a lot of free electrons. So copper will freely let those electrons flow. Most of your metals have a lot of free electrons. That's why metals are good conductors, because they'll let the electrons flow from one atom to the other. They'll flow back and forth, okay? So there's a lot of ways we can get those turbines to spin. We can heat up water to create steam that rises and causes it to spin. We can build big, huge dams like the one out in Nevada, and we can let the water build up behind it, and then we let the water fall and spin the magnets, okay? Here's another video, again, for you guys to watch to help explain electrical energy. But again, electrical energy is simply the movement of electrons. So we've got sound energy, which is the movement of matter, or the vibration of matter, okay? Then we have, what was our second one? Heat energy, which is the movement of atoms and molecules electrical energy, the movement of electrons. And then the last one, electromagnetic energy. All right, electromagnetic energy is really kind of cool, okay? Because if it wasn't for electromagnetic energy, life on Earth wouldn't be able to exist. All right, so electromagnetic energy is a wave of energy that travels because of a changing magnetic field. All right, so again, this magnetic field causes the electrons to move in matter, and it creates this electromagnetic field that travels. Now, the cool thing about this electromagnetic field is that it doesn't have to have matter to travel through. All of our other kinetic energy so far had to have matter. Sound energy has to have something to travel through, whether it's a solid, liquid, or gas. Heat energy has to have something to travel through, whether it's a solid, liquid, or gas. Electrical energy has to have something to travel through, something that's a good conductor, that has free electrons. Electromagnetic energy can travel through nothing because it's a magnetic field. Magnetic fields can go through nothing. Now, the kind of cool thing, this electromagnetic field creates two waves, okay? So it creates a wave that'll kind of go like this, and a wave that kind of goes like this. So you have these two waves kind of going at the same time, all right? And these two waves can travel through nothing. They can travel through a vacuum, or they can travel through empty space, okay? Now, lots of times when we draw our electromagnetic wave, we draw them like this, okay? Because we can't draw a 3D model like this. It's more complicated, all right? But understand that there's two waves, there's two movements, there's two vibrations, okay? Now, here's a couple of examples of electromagnetic radiation or electromagnetic energy. Radio waves. So when you're in your car, you're listening to your radio. Those radio waves are traveling in something called electromagnetic energy. Microwaves. When you put your food in the microwave, you punch your time in and you hit start, it's creating electromagnetic energy that's causing your food to cook. That when those waves like this travel through the food, it causes the water molecules to vibrate. We know when water molecules inside something vibrates, it creates heat energy because they're running into each other, causing friction. Infrared. Some of you guys might have an infrared scanner where you can kind of look at like heat energy. You've probably seen like on TV or maybe like spy movies, like when they put the infrared on and the people walk through and they can see them because of the heat coming off their body. Visible light. So colors, light energy is part of the electromagnetic spectrum. So when we see different colors, that's actually types of energy, okay? Ultraviolet, that's actually a type of light energy that humans can't see, but some animals like bees can see. X-rays, when you go to the doctor and they take an X-ray to see if you've broken a bone, they actually send those waves that are like this through your body, and they can kind of see inside, okay? And gamma rays, like if you watch The Incredible Hulk, you know gamma rays are what caused the Incredible Hulk to get his powers, but that really wouldn't happen. Gamma rays are really dangerous, okay? They're really bad for your body. So are X-rays. That's why if you ever go to get an X-ray, the X-ray technician always has a special badge, and it has a color strip on it, and when that strip turns red, they've been exposed to too many X-rays for the day, they have to leave. That's also why if you ever get an X-ray, they'll come in, they'll put that lead vest on you, if your arm's was broke, they'll put that thing over your arm, and then the X-ray technician leaves the room because they don't want to be exposed to the X-rays. Now, again, electromagnetic energy has wavelengths, just like sound. But sound is a compression wave. So sound like hits, so like this air molecule hits this air molecule, hits this air molecule, hits the next one. This one is what we call a transverse wave, okay? So this one happens, and electricity happens because those electrons flow back and forth. This one happens because they actually go up and down in those orbitals we talked about. I told you didn't need to know about them, but those electrons go up and down in those orbitals, and that causes this wave to go like this and go like this, okay? So you can see that radio waves over here, we have a really long wavelength. And so just like sound, the longer the wavelength, the less energy. That's why these things here, they don't hurt us as bad. Right? You have radio waves traveling through your body right now, but they're not going to harm you because they don't have a whole lot of energy. Visible light doesn't have a whole, the wavelength is not really close together. But you can see up here, once we get up here, like X-rays and gamma rays, those wavelengths are really small. So there's a lot of energy there. Because there's a lot of energy, they're really harmful to our body. Okay, so long wavelength means less energy because there's less movement. Short wavelengths means more energy because there's more movement. Okay? I didn't tell you this like with the sound, but with this, if you kind of think of like, if you ever held a jump rope and kind of flicked your wrist and that hump kind of travels from you to the person over there. Well, the more you do this, the smaller those humps are as they travel. The faster you move your arm, the shorter the distance is between those humps, right? So you had to move your hand a whole lot more to get those humps or those curves to travel from you to that person, okay? So electromagnetic energy, really neat, really cool, okay? Here's another video you can watch. I strongly encourage you guys to watch all these videos. So there's our 4 types of kinetic energy. We'll talk about potential energy later, okay? So if you want to go ahead and read ahead, that's fine. Potential energy is defined as energy matter can possess because of its position. So kinetic energy is because of its motion. Potential energy is because of its position. So they're different. All right. So lots of times people call potential energy stored energy, which for your understanding is okay, but when you get up to high school, that's not such a great definition. All right. So watch the videos that I posted, the YouTube videos, as well as listening to this. Make sure you're getting your makeup work caught up. Okay. Some of you guys have still not done your matter vocabulary and turned that in. Make sure you do that. Some of you still have IXL that you've not done. I've left that open. Okay, you can do that. And again, if you have makeup or missing work in your classwork, you need to do that before the end of the 9 weeks. We're getting down to like 2 weeks left in the 9 weeks, so that stuff needs to get done. All right? So watch the videos, get your work done. I'll have an assignment for you guys tomorrow, okay?